Hello, mathematicians. How are you? Today we are going to continue with our decimals unit. When we met last time, we were focused on decomposing whole numbers into decimal fractions. Today, what we're going to be doing is we're going to be using the information that we learned in our first unit in fourth grade in reference to place value and expanded form to make the connection with decimals. The teaching point today is mathematicians represent mixed numbers with the units of tens, ones, and tenths, with a number disk and the number line, and in expanded form. So we have one goal today. Our goal is to represent numbers with tens, ones, and tenths using multiple strategies, thinking about place value disk, expanded notation, and number line. So I introduced you to some vocabulary um, last week, and I want to introduce you to some new vocabulary. So some vocabulary that we learned last week was decimal point, decimals, and tenths. So I know some of you are jumping ahead, and so I wanted to give you some additional vocabulary or additional representation of the same vocabulary. So last week when I showed you representation of tenths, I showed you that it was the first number to the right of the decimal point. And then we did talk about how it's represented as a fraction, and this is what it would look like as a fraction. For those of you who are jumping ahead, the next place value would be hundredths place. So that's the next place value after tenths. So it's the second place value to the right of the decimal point, and this is how it is represented. Okay, so we're going to watch a video on how to represent mixed numbers with units of tenths, ones, and tens, tens, ones, and tenths with a number disk and number line and in expanded form.
All right, this is fourth grade, Module 6, Lesson 3. And in this lesson, students are going to be experiencing this idea of mixed numbers. And they're going to be experiencing it in a variety of different representations. You're going to be looking at a mixed number, specifically decimals, right? With place value disks, they're going to be looking at these decimals, these mixed decimals, so like 4.3. On a number line, they're going to be thinking about that decimal as an expanded notation, both with decimals, using fractions, using words. I mean, the idea is let students experience a number, 4.3, in a variety of different ways so that students can compare and contrast all of these methods of representations, all these different representations, and develop a really deep understanding of what decimals mean. Rather than just have students think that a decimal is kind of like a whole number except with a dot somewhere. So we want students to have a deep understanding, and that's what this lesson is about. So let's get started. So as an example, let's say we've got our number line up here, and these large hash marks are our whole numbers. So let's just suppose we've got 8, 9, 10, 11, 12, and 13. All right, and I just arbitrarily chose to start at 8. And I worked my way up, a whole number each time. And then the idea is because, let's zoom in between 9 and 10. Let's zoom in between 8 and 9. I want to avoid the number 10. Because we see that between 8 and 9, it's into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember, we're counting the intervals. And so there's 10 intervals between 8 and 9. So that makes these tenths. For example, if I wanted to look at this dot right here, what is the value of that dot on the number line? Where on the number line is that dot? And the idea is, well, we know it's going to be between 8 and 9. So it's going to be 8 point something. So I can write 8 point something. And then we're going to look, and we're going to say, well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 4 out of 10, right, across. So to first think of it as a fraction, we could think of it as 8 and 4 tenths, because it's 8 plus 4 tenths. All right, and then the decimal equivalent of 8 and 4/10 is 8.4. And so we can see the one location is seen as a location on a number line. It's seen as a fraction. It's seen as a decimal. And we could even write it in expanded form. And there's a variety of ways we could write it as expanded form. So first off, I'm going to skip the number line part because it's kind of up here. Right? Now, I like to think of mixed numbers first as a fraction. So that's 8 and 4/10 because we did 4 intervals out of 10. So it's 8 and 4/10. All right, and now I'm going to backtrack and say, well, what's the decimal form? And the decimal form is 8.4. I think the reason I do that is because fractions were invented long before decimals were. And so technically speaking, developmentally speaking, from an evolutionary point of view, so to speak, fractions are easier than decimals because they were invented first. We walk before we run because walking is easier than running. And so because fractions were invented first, they are easier than decimals. A lot of students disagree with me, but that's why I start with a fraction. So what does that look like? And we have a choice. We can do expanded form with fractions or with decimals. I'm going to do them both real quick. So as a decimal, 8.4 is 8 plus 0.4. There's our expanded notation as a decimal. Or we could do 8 plus 4/10. And there is our expanded notation as a fraction. This is important, especially when we start dealing with hundredths or thousandths down the road, especially in 5th grade. So we do want to talk about that expanded notation. Please don't shortchange it. Another way you could think of this is you could say this is 8 ones plus 4/10. It doesn't say we have to do it that way, but there's nothing wrong with adding that as one of our expanded notations. It's kind of like unit form rather than fractions or decimals. And then if we wanted to, how much more is needed to get to the next whole number? And that's a good idea to just help have students develop it. It's kind of like a number bond, really. Or what do you need to add to that 4/10 to get to the next whole number? 6/10. So we could say either 6/10 or 6/10, your choice. So that's the general idea of what's going, and of letting students experience the same value in a whole bunch of different ways, as a decimal, as a fraction, in a variety of expanded notations, plus in relation to the next whole number, wherever we happen to be. So we have more kind of variety of ways for students to think about these numbers. Let's take a look at B. So how many tenths do we have in all? And they have conveniently organized these in 10 frames. So we see 10, 20, 25. So there are 25 tenths. Now it doesn't say so, but 25 tenths could be written as 25 tenths if we wanted to, as a fraction. So I'm not going to write it as a decimal quite yet. We're not quite ready for that. Now over here it says write and draw the same number using ones and tenths. So the idea is to say, hey, wait a second. 10 tenths right here. 10 tenths equals 1 whole. And then we can see, wait a second, over here, 10 tenths equals 1 whole. And then what do we have left over? We have 5 tenths. So that 5 tenths is, we're actually going to have to write that out. So we've got 0.1, and then there's no way to make that more condensed. So we just 2, 3, 4, 5. There we go. So there's our 1 whole. There's our 5 tenths. And by the way, these are not drawn to scale. So it's not like we want students to think that 0.1 is as big as 1 because I drew the circles, the discs, the same size, right? So make sure students don't get
like a misunderstanding there. And so what's our decimal form? Well, our decimal form is 2 and 5/10. So our decimal form is 2 and 5/10. And then right here, how much more is needed to get to 3? And so since we've gone 5 out of the 10 ways, 5/10, so we need 5/10 more. We can either write it like that, or we can write it like that. Here, draw discs to represent each number using tens, ones, and tenths, and then show the expanded form of the number in fraction form and decimal form. So here's our little format here. So 5/10. So what is 5/10 going to look like? Well, 5/10 is going to be, here's a 10, and we need 5 of those. And so there's our 5. And then we need 3 ones, because it says so right there. So we need 3 ones. So 1, 2, 3. And then we need 7/10. So 7/10. So that's going to be a 0.1. And we need 7 of those guys. And so 1, 2, 3, 4, 5, 6, 7. So in fact, let me put it in 10 frame format. So we got the 5 plus the 2 more. So there's our 7. So there is our value using place value discs. And then if we want that in expanded form, so we've got 5 copies of 10. So that's going to be 5 copies of 10 plus, then we have 3 copies of 1. So it's going to be 3 copies of 1. And then it's going to be 7 copies of 0.1. So it's going to be plus 7 copies of 0.1. And there's your answer. And that, what does that equal as a decimal? Well, that's going to be 50 plus 3, so that's 53. And then here's 0.7, so it's going to be 53.7. So the idea is, how can we write that as a fraction? Well, as a fraction, it's going to start off the same way. We have 5 copies of 10, 5 copies of 10, plus we have 3 copies of 1, 3 copies of 1, plus we have 7 copies of 1/10. So as a fraction, that's going to look like 7 copies of 1/10. And that ends up equaling 53 and 7/10. So working in reverse, we want students to be able to see this number and decompose it into its parts.